I'm Ben Sheena with IET. I'm making you this video so you could better understand our PRS-370 decade resistor, which we believe is a superior option for the Navy to purchase instead of our older 1433-29 decade resistor. Anything the 1433-29 can do, the PRS-370 can do, but better. It has a wider range. It goes up to 20 megohm. It has 1 microohm resolution. This unit has 100 ppm accuracy. This unit has 70 ppm accuracy. This unit has better temperature coefficient, better stability. But it's not the specs or the direct features comparison why the PRS-370 is better. It's the additional features that the PRS can offer you. In addition to being a manual decade box that could source out any resistance, like 41.1258 ohms, it's also an IEEE programmable decade box, allowing the Navy to program out your resistance source will reduce mistakes, reduce false calibrations, and speed up calibration processes. The unit isn't a computer and has no security concerns. It has a built-in PIX controller. It doesn't have any Windows, so you don't have to worry about Windows 10 being discontinued and having support issues. It doesn't have a USB, so you don't have to worry about it being deemed as a secure computer. One of the really nice features of the unit is when you are able to use it with an 8.5 digit digital multimeter like the Fluke 8508A or the Keysight 3458. Then it could really turn into a standards level accuracy 10 ppm resistance source that potentially could replace our SRX1 resistors as well. This feature comes included, but you'd only want to use it during when you're looking for resistors of the highest accuracy. Let's say we were trying to source out 12.454 kilo. So you'd source that out standard with 70 ppm accuracy. If I hit the DMM mode, what it does is it's connected right now to the 8508A, and it's working in a feedback loop to produce what it sends is the best combination of resistors in series and parallel to set that value to the Fluke. So the unit has 43 resistors of random values. The unit works off an algorithm to understand what the best resistors to use for any said value. So we're able to get 144.5876. So we're like a 200 milliohms low. So it's going to say, let's try to get 200 milliohms higher. The speed of the unit isn't great because the Fluke 8508 isn't great. It's only in DMM mode that it's not. If we were to use this with the 3458, it's faster. But you'd only want to use this for standards level accuracy. So we were able to get 112.456.003, so now we're a little high. It looks like we're 34 milliohms high. So now it's going to send something in parallel to say, can we get a little lower? And they're just sort of chatting. 33. So it got a value of 12.45603, which is 2.4 ppm away from our requested nominal. Then it gives me the catalog uncertainties of 9.7 ppm. So basically, I'm able to take this to now my device under test, and I have fundamentally a 10 ppm resistor. One of the really nice aspects of the PRS-370 is how it has very limited support issues. All resistors move over time. One of the issues with a 1433 is if enough resistors move out of the 0.01% spec, you then need to replace resistors or replace decades. These decades are sometimes stored on the depot level, Not always. So now you've lost your decade resistor to wait for the depot to send it to you. You also might need a knob or a dial or something like that. This unit embraces the instability of the resistors. It doesn't necessarily care what the value of the resistors that are in the unit, as long as it knows what those resistors are. So, if you can go, it has a calibration mode. So I can run a full calibration. We have it password protected, so soldiers don't mistakenly calibrate it when you don't want them to. Okay, so now what it's doing is, basically, this resistor used to be, R1 used to be 0.17286 ohms. So it's going to go and work with the fluke to say, what am I now? This process is completely automated. It takes about 30 minutes, and it retrains a new algorithm to produce the best values based off the new values. So this is something like 172.85 ohms. So now it's realized this resistor is a little lower and put it in a different chain. It's also very smart. I could just shut it off in the middle of calibration, and I haven't done anything to it. It gives me the version that I'm having on a splash screen, and it goes back to where I was playing with it last, that 12.456 ohms. Additionally, when in my calibration settings, I have the ability to see the full calibration history of any resistor in the unit, when it was calibrated, and I can export it all to a CSV file. So the Navy could very easily understand the calibration history of all of their units. We don't know how you would do it, but if you make a mistake and you set it into a weird mode, you could set it under factory reset, and you'd get it exactly like we chipped it to you in the factory. So we designed the unit to be very durable. You can drop it. I unplugged it, but I didn't really do any harm to it. Okay, and it went right back to the value. We designed the unit with a touchscreen. We've heard that a lot of touchscreens are abused, with soldiers using things like screwdrivers to push the values. This is a capacitive touchscreen, so it prevents you from using anything but my finger. There's also tremendous redundancy, where I have soft keys on the side. The unit is very lightweight and can be just held with a finger. So it's very portable, easy to store. So another nice feature is what you could do in the menu in this unit. The unit could be used in both 2-wire or 4-wire mode. You would just set the mode in the menu, unlike the 143329, which could only be used in 2-wire mode. I have binding posts in the rear of the unit. I could choose the binding post from the rear or the front. One of the most common applications for decade resistors is using it to calibrate RTDs. So rather than sourcing out resistance, we preloaded tables, and you could load whatever table you want in the unit to say, I'd like to source out a specific temperature. Let's say I want to source out 90.2 ohms. In this unit, all I have to go is let's say I want to source at 90.2 degrees. In this unit, I just have to go 90.2 degrees. In this unit, I have to search the table and realize 90.2 degrees Celsius is 98.7 ohms. So I have to go to the decade resistor and go 98.7, and then I have to clear these. There's just much more room for mistake and false failures.